So now let's move on to making predictions using a machine learning model. And there are two ways to make predictions. One is with the predict function, and the other one is with the predict prober, which means predict probability. And this is used for classification problems. So let's go ahead and import the necessary libraries. So import pandas as PD, NumPy as NP. From sklearn.model selection, we're gonna import train test split. And then we're gonna import our random forest classifier. So from sklearn.ensemble, I'm gonna import a random forest classifier. And let's run that. Oh, we're missing an as here. So now let's load our heart disease CSV into a data frame. And you see we have our heart disease CSV loaded into a data frame. So now I'm gonna set up a random seed, put the features and targets into its own variable, split the data into train test split, initiate the random forest regressor, and then evaluate the random forest classifier. So I'm gonna put comments for everything I'm doing. So np dot or set up the random seed. So np dot random dot seed, and like I said, if you're following along, our data will be shuffled the same way. Next, we're gonna put features in X and target in Y. So X equals disease.drop, and we want everything in the data frame except the target column. Then we set the axis to equals 1 because we're dropping the column. And we set Y to equals heart disease, the target column. Next, let's split the data into training and test sets. So X train, Y train, X train, X test, Y train, Y test, set that equals to train test split. Arguments it takes is our X and Y, and then our test size. We're gonna put 80% or 20% of the data into the test, leave the remaining 80 for the train. So next, let me instantiate the random forest classifier. And then I'm gonna give it the variable CLF equals random forest classifier. And then I'm gonna fit the training data. And this is where the training happens. Train, Y train. Next, I'm gonna evaluate the random forest classifier. So CLF.score. And in the arguments, it takes our X test and Y test. And let's run that. Hopefully there's no mistakes. And you see we got a score of 85%. So let's quickly look at the X test. Dot head, let me just bring the top 3. And then I want to make some predictions on the X test data. It's CLF.predict. Let me run that. And these are the predictions using the test data that our model hasn't seen. So our model hasn't seen these features or these values for the features. And this is the predictions that it's make for each row in our X test. And according to our model, it's gonna get it right 85% of the time. So let me look at the Y test. P dot, and we gotta put it in an NP array, Y test, and let's run that. And these are the truths or the actual answers to the data in the X test. So these are the predictions and these are the actual correct answers. So for this first row, our model predicted that someone did not have heart disease, and you see the right, it got it right. And for this row, the model predicted that someone has heart disease, but our model got it wrong because we're looking at the actual answers. This is why we split our data into training and test sets, so we could do the evaluation on the test sets. And you see here for this row of data, it says someone has heart disease, and it got it right. And then here it got it right, here it got it right. Let's see until when it got it wrong. And this is the next time when it got it wrong. And according to our score, it's gonna get it correct 85% of the time. Another way we can get the score, the score of our model is using the accuracy score from sklearn metrics. So let me just write a comment. Another way we can get the score is by using accuracy underscore score from sklearn metrics. So let me import it from sklearn.metrics, import accuracy score. But first we should get the Y predictions in a variable. So let me write a comment. First we should get the Y predictions in a variable. So set the variable Y predictions equals clf.predict. And we're predicting the X test, which is this. So we're just putting this in a variable. And then we call our accuracy score function from sklearn. And then it takes our Y test and then the Y prediction variable. And let's run that. And you see we get the same 85% that we got here when we use the score function. So here's a side note. We can put our own features to get a prediction. We just have to put it in order of the data frame. So let me look at the xtest.head again. So to make our predictions, our own predictions, clf.predict, I'm gonna put it in an array. And we're gonna put our own values for X so that it gives us an output to whether someone has heart disease or not. But it should be in order and the same amount of features. So for age, I will put 62. For sex, I'm gonna say it's a female. CP, I'll get the value of 2, 160, 270, 1, 0, 119, 0, 0.4, 1, 0, 0. So let me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It should be 13 values here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now let's run that and see what it gives us. Whether it's... Oh, I spelled array wrong. Let's run that. I need to turn this into a 2D array. So in order to do that, I'll put 2 block brackets on each side. And let's run that. Our model took in these features, and then it gives us the answer that this person, based on these features, has heart disease. This is just a warning. If you want to remove this, you can import warnings and warnings.filter warnings, and we could just ignore. Let's run that. It's warnings with an S, and you see our warning was removed. So these features, our model predicted that this person does have heart disease. So now let's move on to making predictions with predict prober. So making predictions with predict prober. So predict prober returns the probabilities of a classification label. So let me call out clf.predict_prober. and then we're gonna put X test, and let me just get the first 5. And it's indexed, so this side is 0 and this side is 1. So it predicted that there's an 89% chance that this person does not have heart disease and an 11% chance that this person does have heart disease. So our function with predict, it will only output 0 to show that this person does not have heart disease. So let me use the predict quickly. CLF predict. I'm gonna do the X test and only 5. So like I said, 89% that it doesn't have heart disease, so we get a 0 here. For this one, it's 51% that the person does have heart disease, so we get a 1. Here, there's a 57% that the person has heart disease, so we get a 1. And this is in the 1 index, so it will give us a 1. Here is 84% that someone does not have heart disease, so we get the 0, and so on. So predict will give us a single label for each sample, while predict proba returns the probabilities of a classification label. Predict can also be used for a regression model. So let me quickly do that. Give an example with a regression model. So let's call it our housing data frame. Housing underscore data.csv. Let's take a look at it. Housing.data frame. And this is our housing data. So now let me set up a random seed. So np.random.seed. Set that to 42. If you set it to 42, our data will be shuffled the same way. Let's put our features in X and our targets in Y. So housing underscore data frame dot drop. We want all the columns except the target column. Set the axis to equal 1 because we're dropping the column. Set Y to equal to a housing underscore df target. And now let's split it into training and test sets. So X train, X test, Y train, Y test equals train test split. It takes our X and Y. We want the test size to be 20%. Now let's create our random forest regressor. So model equals random forest regressor model.fit, which takes the X train and Y train. So this is where the training happens. And let's put our predictions into ypreds. So ypreds equal to model.predict. And we want to make the predictions on the X test. And first, we have to import the random forest regressor, because if we don't, this won't work. So from sklearn.ensemble, let's import random forest regressor. Now let's run that cell, see if everything works. And you see we have no mistakes. So now let's look at the predictions using the test data that our model haven't seen. Now let me just cut 10, spread with an S. And these are the predictions of the price of the houses. So our model take the data or the features that it hasn't seen, which is the X test, and then it made these predictions with it. So now let's look at the actual answers, which is the Y test. I'm just looking at 10 of them. I don't want to see all of them. And now let's run that. So our model predicted that this house costs 0.49901, and the actual answer is 0.47700. So it's off by a little. And we see this one, the model predicted that it's 0.74. And here we have 0.45. Here the model predicted 4.3 or 4.93. And here the actual house price is 5. So using our random forest regressor, we could see that the values are not that off. Here the actual is 2.1, and here it predicted 2.5. Later on in the course, I'm going to show you how to evaluate a regression problem model. So these are the predictions, and these are the actual values or the actual prices of the houses. We can make predictions with our own input. So let me take a look at the features. Let's run that. And now let's make predictions with our own input. So model.predict. We will put it in an MP array. So I'm just gonna give values, random values for each of these columns and see what we get. So 1.5, 32, let me see, 2.5, 1, 1400, 3, and I'm gonna say 38.1, and then since there's a negative number, let me just give a negative 115. Let's run that. And this is the prediction it gave us from inputting our own values.